study about the force system. Forces of all types may cause subluxation, dislocation, fracture, strain, and sprain, etc. The biomechanisms involved will determine the type and the extent of the injury produced depending upon the applications of force and its resistance. For example, different application of force may cause bending, stress, or compression fractures. To further understand how an injury was caused, which tissues are involved, further you study about linear, concurrent, and parallel forces and their effect upon equilibrium. However, forces acting on a body are sometimes neither linear, concurrent, or parallel. Therefore, general forces are always include at least 4 forces are required to maintain an equilibrium. So in this lecture, we're going to study about linear, parallel, concurrent, and rotational forces from the force system. Linear forces are those forces which act in a straight line in a same direction. If two forces are to be in equilibrium in a linear system, the forces must be equal in magnitude and object will move in horizontal direction and gives a compression effect. Example of linear force system is pulling on wood cart. For example, if a horizontal push is applied to a piece of furniture and push is at the line of object center of gravity, the object will move in horizontal direction. You know, much of the physical therapist work involves the application of forces either to oppose them or to equate or to enhance the forces of the muscle action and the effect of the gravity upon them. Examples of linear forces are rare in the human body, but still here is an example where two or more forces are acting at the same point and at the same direction at ankle joint. Gastrocnemius and soleus muscles are applying forces in same direction and at same point. Both of the muscles have a common tendon for a distal attachment. Imbalancing of the one muscle force can cause gaze disturbance and pain. Okay, now if linear forces are applied along the same action line but opposite in direction, it results in equilibrium and no motion would occur. Example includes tug of war. Forces are applying by object in opposite direction. The movement will be in the direction of greater force because of the strength and the force applying by the opposite. But now when two forces are acting opposite to each other with equal magnitude, it results in equilibrium. And this example includes a compressing of a soft ball by using your both hands. Clinical example includes a weakness of iliopsoas muscle. The iliopsoas refers to the joint that joins psoas and iliacus muscle. The two muscles are separate in the abdomen but usually merged in the thigh. As such, they are usually given the common name iliopsoas. The iliopsoas muscle joins the femur at the lesser trochanter and acts as a strongest flexor of the hip. Psoas major and the iliacus muscle act along the same action line means that they have a same point of application and act in the same direction. The resultant force equals the magnitude of two forces, but weakness of the one muscle will reduce the magnitude of the resultant force. After the linear force system, the second force system is a concurrent force system. In a concurrent force system, as contrasted to the linear system, the forces acting on the body meet at certain points rather than they lie along the same line of action. These forces may be applied to the body from the different angles so that their action line cross either interior or exterior to the body. Let's see an example. Here are two people pulling the boat. Solid line represents two concurrent forces in the middle, which is the resultant force, and the dotted lines are drawn to complete the parallelogram. Over here, also diagonal will move toward the strong force side. This figure is another example of concurrent force system. Now you can see two people pushing at different angles to each other through a common point of application. Routine example includes if several football players opposing each other in a blocking situation, applying forces at same point from different or opposite angles. Example of concurrent force system occurs in the body when the deltoid muscles contract during shoulder abduction. The action of anterior and posterior fibers of the muscle being compounded to work with the middle fibers and seamlessly increasing their power. Now talking about the third force system. When the parallel forces some distance from each other act upon a body, their forces must be completely nullified by each other if the body have to maintain the equilibrium. If the forces do not coincide at the same point, such as in a concurrent system, the result is rotation around the stationary axis. A simple form of this action is a force system where the forces lying in the same plane are parallel. Any force acting on an object at a distance from a fixed point tends to rotate the object. Forces producing clockwise rotation are arbitrary, which is referred as positive, while the counterclockwise forces are termed as negative. A very common example of this force system is when two people lift a weight. Another example of parallel force system is a seesaw. When both kids are applying same force, they are in neutral position. As one side force increases, the other players will move upward. Clinical example of parallel force system includes when you hold a ball with flexed elbow. So the angle of pull at biceps is 90 degrees. The force of biceps acting in upward direction while the force of gravity which is acting opposite direction from two different points. That forms forearm and a weight of a ball. Here all three forces are parallel to each other but acting at different points. Another example includes a body brace which is used to stabilize the spine. Now if you look at the figure that have the forces x and y and which are parallel in same direction, while the force z is parallel but acting in opposite direction. So the force z must be between the forces x and y in order to provide the stability. If the force z was at the either end instead of the middle, so the motion would occur. In parallel force system, any of the force which is greater than the other resultant force, the rotation would occur and it is said to be a rotational force. For example, if you are opening a lathe, rotational forces will be applied. Rotation is defined as the circular movement of an object around a center. It is possible to rotate different shapes by an angle around the center point. In three-dimensional shapes, object can be rotated about an infinite number of imaginary lines which is known as rotational axis. Whereas revolution is defined as the act of revolving or turning around on an axis or a center, the motion of a body around a fixed point or the line of rotation. Example includes the revolution of a wheel. If you notice, rotational forces act when the trapezius muscle and serratus anterior muscle contract to rotate the scapula. Thus, the principle of compounding forces is also employed in some arrangements for balance traction. In outpatient department, halter traction is used to give traction to head, whereas orthopedic traction is used in inpatient department. Usually, many forces act on the human body simultaneously. It is important to know the final, that is the combined effect of these forces, which is known as resultant force. Therefore, resultant force is defined as the sum of all forces acting on a body or a body segment. A parallelogram shows graphically the resultant force of two concurrent forces pushing on a chest of drawers. So concluding that resultant force of unequal forces moves towards the stronger force.